It's Mr. Harris. He's now awake. He's had some Coke, which means he's now had some caffeine and he's like, buzzing. But no, today's lesson's a bit different from normal because today is not about me teaching you a new topic and assuming you know nothing. What I'm going to do a bit different today is the activity sheet or the exercise I've copied in the link below contains a variety of questions. I have selected 3 of these questions for me to go through with you. But what I really want you to do, and although this is like a live lesson, I really want to encourage people to actually try the questions first. So I have no problems with anyone disappearing from the questions or pausing the video when we get to the questions or going away now, stopping the video, going and downloading the sheets, because I think it's going to be really useful to have a go at the questions before the go through. Otherwise, you won't know what you could already do and what you're just learning from me. So I'm actively encouraging you to do any different approach you want. I am going to show you the worksheet is in the description below. I'm going to go through a few of them in the way I would do them, but I really want you to feel that this is an approach to help you as if you're being tutored. So you need to be able to have a go at it yourself rather than just, I'll watch Mr. Harris and see what he does. Because that's passive and I'm encouraging you to be active. Okay, let's get straight on with it. So, just before I get started, let's say a few hellos. I look sideways when I say hellos. Hello Alicia, hello Harry Sharp, hello Eddie, hello Star Wars Gamer. I do not know your name. Please do consider putting your name when you write your comments as well. Alicia, good morning to Nina. Good morning. Anyone else who's with us who has not commented. So thank you very much for joining the video live. Like I say, there might be other people joining live. There might be lots more people who watch it not live. What I wanted this to be an active approach. So, without further ado, let's go straight... I say that all the time, don't I? Without further ado, let's go straight into the screen. Now, this is the first question I chose. I chose question 3. There's 2 bits here, and these are area problems. Now, all the problems we're doing today are to do with finding the area. And I'm going to try and take them apart as I would do it. So, if this was a question I was doing, I would first off... By the way, very exciting news. I didn't have a chance to set it up, but this has just arrived. This is my brand new writing pad. It hasn't been plugged in yet, but this is very exciting. This is going to take over from the one that's been breaking and not working properly. So from next time, this is what I'm going to be using. So first thing I'm going to do with the last lesson for my old writing pad. Poor writing pad. So these are the key bits. I always feel that underlining the maths helps you take apart a question. It says calculate. This does not mean use a calculator, although it doesn't say whether you can or can't. But it does say calculate means to work out. The area is the space inside each of the following shapes. So the first thing I would do when I see a shape like this, there is no rule for these shapes. What you can do is break them into shapes you know. This is possible. I could have done it this way. And in fact, I could have done it this way because I do know a rule for trapeziums, but I feel that that's a little bit extra when I didn't need to. Once I've cut it into the components, this is going to be 4 times 6 is 24 centimeters squared. And I normally write it, if there's space, I write it inside the shape being done. This one, I don't know this length, but I do know that this is 6. And I also know that this is 2. And this is where we have to use a bit of detective work, a little bit of thought. You can't just look at the question and go, I can see numbers, I'm going to time them together. That's not how maths works. If that's what you want to do, you're welcome to do it, but you'll get all your questions wrong and you won't learn anything. If you're here to learn and here to understand, we need to realise that if that's 6 and that's 2, then this side must be 4, because it's the missing bit from 6 when you take 2 away. This means this is 5 times 4, which is 20 centimeters squared, which means the overall is 24 plus 20 is 44 centimeters squared. It then says give your answers correct to 3 significant figures. This has only got 2 significant figures. Significant figure means from the front of the number. So let's say I had 6,923. I would go 1, 2, 3, and I'd only include those. So it would be 6,920. However, this is not big enough that I need to do that. Therefore, I don't change it at all. The next one, I can see 2 approaches. And I'm going to do my second approach, even though I do concede I could have done, just like in the first one, I could do that and work out 3 different areas. I'm going to choose not to, and I'm going to change the colour because I want to demonstrate I'm doing something different. What I'm instead going to do is I'm going to do this bit, and I'm going to do the whole of the outside thing. Then I'm going to do the small bit, and I'm going to take it away. In the first one, I did the 2 separate bits and added them. In the second one, I'm going to do the whole of the big bit, and then the whole of the little bit, and take them away. So, what we've got in the big one is 12 times 6 is 72 centimetres squared. In the small one, we've got 3 times 2 is 6 centimetres squared. So we've now got, I think, 72 minus 6 is going to give us 66 centimetres squared. So you don't always have to do addition. In this case, I've used subtraction because I could do it in 2. I could have broken it into 3 parts and it would still have given me the answer 66. But I felt this was a nice quick way of doing it, is to do the whole of the outside and imagine it was completed. Then do the small bit and take it away. This is a common strategy for questions like this. Remember, the worksheet, if you've just joined or if you're late to this, the worksheet is in the description below. I'm encouraging you to pause and not necessarily stay live with me. I know this is weird to have a live lesson where I encourage you not to stay live, but imagine a classroom where the lesson continued at the speed you want it to. I think that's more powerful. Yes, it's nice to be able to chat to me and ask questions in the live chat, and if I'm still here, I'll be looking at the questions that people ask. However, it's more powerful to be able to go at your own speed and do the questions as we come to them. With that in mind, the next question I've written is this question. It's one, I think it's like about question 8 in the booklet, but it's this question here. To do so, I'm going to need, first of all, area and 1 decimal place. Now, if you are year 5 or 6 and you've come here because you want to see what they do at secondary school, or if you're in year 7 and you've not come across this yet, the first thing I'm going to do is write down that the area of a circle. Remember, please pause this if you want to do the question first before seeing how I do it, because there's nothing worse than watching me do it and then you're not actually able to learn anything yourself. Please don't just listen passively. Try this question yourself first and then see if you get the same response. The area of a circle is pi times radius squared. I use the little song, circumference is pi times diameter, pi times diameter, pi times diameter, circumference is pi times diameter, area is pi r squared. Now the second bit tells me I'm going to need my calculator, so I'm going to reach behind me and grab it. And it tells me that because it says it wants it correct to 1 decimal place. There is a way you can do it where sometimes you'll get a question, it doesn't actually ask you to work out the decimals. And that would say leave your answer in terms of pi. If you ever see it says leave in terms of pi, you don't actually work out what pi is, you just leave it as a number, and that would be a whole number. But we're not doing that. We're doing 1 decimal place. So we know we're going to use a calculator, so I've got my calculator here. This is where 2 people might get different answers, but they're both right. Because I'm using the pi button on my calculator, which means I'm using a button that in the calculator's head is 3.1415926533589673284626433832794419716993 and so on. However, you could just use 3.14 and you'd still be right. So you don't have to use the pi button. But what I'm going to do is I am going to first off look at this question. I think here that bit can get stuck to that bit. I'm going to draw out the shapes I'm working with. I am going to draw the big rectangle. I am now going to draw the big circle, which is in two halves, but we could put those two halves together. And I'm going to draw the smaller half circle. Now, I did say it's r squared, and the radius is not the 5. The radius is 2.5 here. And the radius of this one is 2. You must remember to get the radius if we were dealing with our area. Now, hopefully you can all agree to find the area of the shape shown, because the dotted line means that those bits are missing. What we're going to need to do is going to find this area and take off the cut out bits. So let's work it out one step at a time. The big bit, I think 1 and 4 and 1 is 6. 2 and 5 and 9, 2 and 5 and 2 is 9. So I think we've got 6 times 9 is 54 centimetres squared. I'm sure if anyone's not clear on anything, they will ask. Good afternoon, Bionic MO. Nice to meet you. Hello, Claire. Good to see you. I imagine that must be William. Any more people join, I will try and say hellos. So, pi r squared is going to be the calculator pi times 2.5 squared. Is going to be, the calculator tells me an answer of 19 point, and it says 634, but because of our one decimal place, 634 just rounds to 0.6. Okay, if it was 68, we'd have rounded up to 0.7, but it doesn't, so it stays there. Centimetres squared. And my half circle is going to be pi times 2 squared divide by 2. The reason for the divide by 2 is we want a half circle, not a full circle. So it's going to be pi times 2 squared and then divide by 2. And that again gives me an answer of 6.28. But 6.28 is 6.3 when we round. Now I've done something bad here. Normally you should not round all the little individual bits. You round them at the end. So what I'm going to do is I'm going to add the actual numbers rather than the rounded numbers, because Mr. Harris should not have been rounding. You should never round during the event. Plus 54. And I make the total here. Mr. Harris has messed up here. It's 54 take away, isn't it? So it's going to be 19.6 plus 6.3. So this will give it a rough answer. 54 minus that. And I think if we do 54 minus 19.6 minus 6.3, we get 28.1 centimetres squared. So what I've done is I've done the rectangle. I did the whole of the rectangle. Then I cut out, imagine some scissors. I don't know if it's slightly behind there, so I imagine some scissors. And I cut out round there. And I cut out round there. And I cut out round there. And that radius was 2. And that radius was 2.5. Because remember, the radius goes from the middle of the circle to the edge. Okay, so that is how I worked it out. And what I did here, rather than doing 3 different bits, I noticed that these circles are the same. So putting these 2 half circles together gave me a full circle, which is why I was allowed to do this one as a whole circle with the 2 halves together. Took it all away, and that's how I got that answer. So again, I'm encouraging you to pause, check your answers, check you can do the same as what I've done, and then move on at your own speed. I'm obviously ready to move on, and this is the third one. This is why I had the picture at the start of the lesson of the shape sorter, because here is a child shape sorter, and we want to have the area of the lid, but obviously the lid does not contain the gaps where the shapes have to be put through. Now what I'm effectively going to do is I'm going to have, if we use the same idea as before, remember you can pause it now, I am going to have, it says again 1 dp, 1 decimal place, and it wants to calculate the area. I am going to first off find the area of the whole rectangle. Then I'm going to want to take away the circle, take away the square, take away the triangle, and take away the parallelogram. All of these I've done primary lessons on how to do the area of each of these, and I did a transition one on area of a circle way back, about 10 weeks ago. But we're first of all going to find the long side. It was 14.2 and 10.5. So we're going to multiply those together. I'm not rounding yet, so 14.2 times 10.5. I'm going to put the entire answer, which is 149.1. This one, the radius equals 1.5. This is important. You have got to remember that the radius is half of that circle. So therefore, we have pi times radius squared is going to be pi times 1.5 squared is 7.06. Now, I am not rounding this. So I'm leaving this in a calculator at the moment. And when I put ... that is a way in maths of showing that the number has not been rounded. So with no rounding has taken place, but there are more digits that I haven't bothered writing. This one is going to be 2.8 times 2.8. So the area is going to be just 2.8 squared. Is 7.84. This one, remember base times height and half it. If you do not halve it, you have gone wrong. This is important. So it would be 4 times 3 and halve it, so the answer would be 6 centimeters squared. And then finally, for a parallelogram, it is base times height. No halving for a parallelogram. However, let me make that neater. However, to do base times height, you've got to imagine looking at it from this direction. So it would be 5 times 1.2, which I believe is 6. So what I'm going to do is I'm going to do my 149. So 149.1 minus the whole of that number, so pi times 1.5 squared, minus 7.84 minus 6 minus 6. It doesn't like it. So 149.1 minus pi times 1.5 squared minus 7.84 minus 6 minus 6. And it gives me the answer 122.1914. Then, because it says 1 decimal place, I then do a round. 122.2. This answer should be 122.2 because we do all of the calculations and then round at the very end. Sebastian, you're a bit stuck. You're asking the right thing. You got stuck on the area radius bit. So the formula for the area of a circle is pi times radius squared. But to do that, we need to know what the radius is, and then that will always be halfway across the circle. So any of the questions I've done for you, Sebastian, where I'm talking about the radius of the circle, all you do is you look at, well, if it's all the way across is 3, it would be 1.5. If I go back up to the previous question, all the way across is 5, so halfway is 2.5. All the way across is 4, so half is 2. Anytime I'm dealing with circles, to get the radius, I go halfway across the circle. So it's going to be whatever the diameter is, and I halve it. Hopefully that's useful. If not, feel free to ask me comments or send an email because I've got my things. So that is 3 of the questions. I've spent 20 minutes going through them. And I'm now going to try and spend 5 minutes in the chat with people. Hopefully this has been useful. But what I would like you to do is now carry on the different area questions and use the comments almost like this is a lesson that's going to carry on now. If you're stuck on a question, use the YouTube video comments to ask about it. How do I do question 6 or 9 or 12 or 13? And I can respond, but also other students can respond on how to do it. And it makes it more interactive. So this lesson can last weeks, months. You could even be having people revising for their GCSE and in a year's time and coming up with these same sort of questions. So it's all useful stuff. So please consider writing any questions to any of the other stuff on the comments to the video. Hopefully, Sebastian, please, I understand fully why you did, but consider not retracting your messages, because your questions were very good. And it's useful for other people to know from seeing your question why I was talking to you and what I was talking to you about, because they can look back, even like in 6 months' time, they can look back and see your thing. So please consider not retracting messages. There is no such thing as a bad question. There's no such thing as a problem for not, you're not in trouble for not understanding. So please consider that. You're not doing anything wrong. I'm just encouraging people to keep their questions visible for people. So anyway, that's the end of today's lesson. I've been Mr. Harris. I'm going to put the funky music on and get Alicia dancing again. I hope you are all well. I will be with you again on Friday, where we're going to be going some EDOC challenge. Remember, EDOC challenge, read EDOC backwards and you might work out what that's all about. I've been Mr. Harris. You haven't. Look after yourselves and take